Hello everybody, so we're going to continue with our pursuit of solving system of linear equations, and we're going to look into one specific method called the substitution method. So let's begin with an example. I have two linear equations. The first one is x plus y is equal to negative 5, and the next equation is negative 2x plus y is equal to 1. So I'm just going to label them. This is equation 1 and this is equation 2. And the idea behind using the substitution method is that we want to look at one specific equation, either the first or the second, it doesn't really matter, but we want to solve for either the variable x or the variable y. Once we have that solved, you want to substitute that in to the equation that we didn't change in order to solve for the variable. So what I'm going to do is I'm going to take the second equation and I'm going to solve for y, and I'm going to do this on the side right here. So I have negative 2x plus y is equal to 1, and I want to isolate y by itself. So we'll begin by adding 2x to both sides, and we have the equation y is equal to 2x plus 1. So now with this equation, we want to directly plug that in to our first equation in place of y. Alright, and we're going to do this in the bottom. So we have x plus, instead of y, we have 2x plus 1 is equal to negative 5. Now we want to combine like terms, so we have x plus 2x gives us 3x plus 1 is equal to negative 5. Next, we want to isolate our variable, so we subtract by 1 to both sides, and then we're left with 3x is equal to negative 6. We solve for 3, we divide by 3, and then we get x is equal to negative 6 divided by 3 gives us negative 2. So we found our first solution. And next, we want to plug this in to either equation and solve for y. So we'll plug it into the bottom one this time. Negative 2 times negative 2 plus y is equal to 1. Negative 2 times negative 2 gives us a positive 4, plus y is equal to 1. Minus 4 to both sides, because we want to isolate the variable. We get y is equal to negative 3. So when we have a solution for a system of linear equations, it's always going to be as an ordered pair. So when we write our solution, we're going to write negative 2 comma negative 3. Now, just to cap everything all up, if I were to set the first equation and the second equation both in slope-intercept form and graph them, the lines would intersect at this point right here, negative 2 comma negative 3. And with that, we just utilize the substitution method in order to solve a system of linear equations. Thank you very much.